What is up, guys? Welcome to Barton. My name is Heinrich, and today we're adding the ability to wall jump to our player. So seeing as we already have our ability super state set up from before, adding the wall jump state is going to be super simple. But before we get started with that, we just have some things that we need to fix from the previous episode. So if we go into Unity, so in the part where we added just the normal jump, I forgot to do something in the player in air state. So let's go ahead and open that up. So the thing that I forgot to do is to tell our input system that we use the jump input before we transition to our jump state. So over here we have else if jump input and player jump state.can jump. Right before we call change state, we just have to say player dot input handler dot use jump input. And as far as I can tell, that's all that we've forgotten so far. Now we just have one more issue, and this comes from a bug that somebody else pointed out in the comments. And we can quickly see if I can recreate it. If we run and we spam jump, as you can see there, sometimes we get lucky and we get a double jump, even though our character does not have a double jump. And that comes from a pretty big flaw in my code so far, but we have a very simple fix for it. So before I show you guys the fix, let me quickly explain what is happening. If we take a look at our player in air state again, the reason we have this if, else if for all these state changes is because if we're grounded and we want to transition to our player land state, we don't want any of these other state changes to interrupt this state change. So right here, it's working the way it should. But if we take a look at our player move state, we have this one state change over here. The rest of our state changes all happen in our player grounded state. So let's click on that. As you can see over here, we have an if, else if with different state changes. But what's happening is, say we're in the move state, right? When the logic update starts, we call base.logicUpdate, which means we're coming to our player grounded state. And so it's going to come into this logic update function, it's going to read in our input, and then it's going to check these state changes. Now, if one of these state changes get triggered, so say for instance, we did give jump input, it's going to call change state.player.jump state, and then it'll skip all these else ifs. But then before we're officially in the new state, we're going to come back to player move state because we just called this base.logicUpdate, and we're going to run this code. So now what could potentially happen is this condition is met, and so we change to the idle state instead of actually changing to the jump state. And because we change to the idle state, that means the amount of jumps that we have left gets reset because we're technically transitioning to a grounded state. But because we did transition to our jump state and the enter function sets our y velocity, we still get the jump. So now how do we fix this? The fix is quite simple. All we're going to do is in the state, keep track of if we've initiated a state change. And if we have, then these children states will not get to run this code. So let's go ahead and go to our player folder and open up our player state script. So that's under player finite state machine, player state, and let's declare another protected bool. And let's just call it is exiting state. Then we can come down to our enter function and just set that to false by default. And then in our exit function, let's set that equal to true. So now whenever we initiate a state change, our current state will have this boolean set to true. So then we can come to our player move state. And over here we currently only have one possible state change. So we can just, in this if statement, add and not is exiting state. We also need to come to our player idle state. And again, we only have one state change, so we can just add that in here. So and not is exiting state. And then finally, we also have our player land state. So let's go ahead and open that one up. Player states, substates, player land state. So here we currently have two different possible transitions. So instead of adding not is exiting state in each of these, let's just enclose this in another if statement. So if not is exiting state, then we want to do this. Just like that. So if we take a look at our state machine diagram, this isn't something we have to worry about in our ability states because none of these states transition to each other directly. But we do need to do this in our touching wall states as well. So let's open up our wall grab, wall climb, and wall slide states. And let's just add that to these if conditions as well. So, and not is exiting state, and then our player wall grab state. Here again, we have two different state transitions. So let's enclose this in another if statement. And then finally, our player wall climb state, again, only has one transition. So, and not is exiting state. Perfect. So that should get rid of the little issue that we had, and this should make it a lot better going forward. We just need to make sure now that we remember to add this not is exiting state to our new states. Okay, so now we can get started with our wall jump. Let's go back to Unity. And this time the only new script that we need to create is our player wall jump state. So let's create a new C# script, and let's just call it player wall jump state. And let's go ahead and open that up. So just like our normal jump state, our wall jump state is going to inherit from player ability state. So player ability state. And let's go ahead and generate our constructor as well. Boom. And now before we do anything else in this state, let's go ahead and open up our player script so that we can create the object. So firstly, we come to our state variables. Let's create a public player wall jump state. Call it wall jump state. And then give it a public getter and a private setter. We can go ahead and minimize our state variables. Now we just need to instantiate the state in our awake function. So wall jump state equals a new player wall jump state with this as our player, state machine as our state machine, player data as our player data, and then finally our animation boolean name is also just going to be in air, same as for the jump. And that's basically all the setup we need to do. We're ready to get started with the state. So let's take a little look at our state machine diagram here. So we transition to our wall jump state if we get an ability input, in this case our jump input. Now we won't wall jump from our grounded state, so we don't have to worry about creating a transition from grounded to wall jump state, but we are going to have transitions from our in air state to our wall jump state and from our touching wall state to our wall jump state. So let's go ahead and just get started with our in air state transition. So let's go back to our player in air state script. And so currently we have this else if jump input and player.jumpState.can jump that lets us transition to our normal jump state if we have the ability to double jump. So we want our wall jump to take preference over our normal jump state if we're touching a wall. So we're going to put another else if before this else if. And this time our conditions are again going to be jump input and is touching wall. So if we are touching a wall and we give jump input, then we want to wall jump. So we'll just transition to our wall jump state with state machine dot change state to our player dot wall jump state. And that's basically all we need for now. We'll come back and add a few more things here in just a second. Let's go ahead and start with the player wall jump state. So before we do anything, let's go ahead and generate our overrides. And really we only need our enter function and our logic update function for this state. So once we enter our player wall jump state in the enter function, we need to set our velocity. But before we can set our velocity, we need to determine what direction we want to set our velocity in. So are we wall jumping left or are we wall jumping right? Now there are a few different scenarios. Let's quickly go to Unity and I can just explain. If we take our player, let's move him around a little bit. So say we're coming over here and our character is touching the wall like this. And now we want to wall jump. So we push the jump button and now we're going to flip the character and wall jump this way. So now in this case, the character should be facing left. So now let's say right before we push the jump button, we give a positive X input. So our character flips to face this way and now we push jump. So now our wall jump direction is going to be the same as our facing direction. Whereas before, in this case, when we're facing the wall, our wall jump direction is going to be negative facing direction. So how do we determine what direction our wall jump should be in? And so to do this is actually quite simple. We have a ray being cast out to the front to detect a wall. So we're going to cast another ray out to the back to see if we're touching a wall behind us. And then based on that information, we'll choose whether our wall jump direction should be the same as our facing direction or different to our facing direction. So let's go back to our script and let's create a new function over here that is going to be public void, and we'll just call it determine wall jump direction. And this function is going to take an input of type Boolean, and we'll just call it is touching wall. So now inside this function, we're just going to set our wall jump direction. So we have to come up and declare a private int that's going to store our wall jump direction. So like that. And now inside this function, all we say is if is touching wall, then our wall jump direction is going to equal our player dot facing direction, else wall jump direction is going to equal negative player dot facing direction. Okay, so I made a mistake in the player wall jump state. In the determine wall jump direction function, if is touching wall is true, that means we're facing the wall, then our wall jump direction should be negative player facing direction. Otherwise, it should be positive player facing direction. So now, where do we call this function from? We're going to call this before we transition to our player wall jump state. So right now, we want to come and call it in our player in air state. So over here, we'll just say player dot wall jump state dot determine wall jump direction. And to this function, we're just going to pass is touching wall. Now for this function to actually mean something, we also need to do the check for a wall behind us. So let's come to our player script, and in our check functions region, over here we have a check if touching wall. Let's just go ahead and copy and paste this. And then let's just add back to the end of the function name. And we're going to return the same thing, except our direction is going to be negative facing direction. So now back in our player in air state, we can go ahead and declare another Boolean. So private bool is touching wall back. And then let's add that to our do checks. So is touching wall back equals player dot check if touching wall back, like that. So now we can use this information in our logic update. So when we say jump input and is touching wall, we can also say or is touching wall back. And then we also just need to put brackets around the two is touching walls. So what's happening now is if we're not touching a wall in the front, but we are touching a wall in the back, and we give jump input, we can still wall jump, and then we're going to tell our wall jump state if we're touching a wall in the front or not, and it's going to use that information to determine which direction we should be wall jumping. So now we're almost ready to set our wall jump velocity. The last thing we need to worry about is how do we set that velocity. In our player script, we currently only have two velocity set functions, one for x and one for y. But we want our wall jump to be at an angle, and we don't really want to be calling both of these functions. So let's create another set velocity function that's going to take in a velocity and a direction and an angle, and then just set the velocity from that. So let's just go ahead and create another public void. And this one we'll just call set velocity. And this function is going to take in a float called velocity, and then a vector2 called angle, and then finally it's going to take in an integer that is our direction. So now inside this function, the first thing we're going to do is normalize our angle with angle.normalize with a capital N. We just do this here, that way we don't have to worry about normalizing our angle every time before we send it through to this function. Next, we can set up our workspace. So workspace.set, and our x is going to be angle.x multiplied with velocity, then multiplied with direction. And then for y, we have angle.y multiplied with velocity. And then next we say rb.velocity equals workspace. And then finally, we just have to update our current velocity. So current velocity equals workspace. Okay, so we're almost ready to set the velocity in our player wall jump state. The last thing we need is our wall jump state data. So let's go ahead and open up our player data script. And let's go ahead and create a new header for our wall jump state. So just call it wall jump state. And so the first thing we need is going to be our public float wall jump velocity. And by default, we'll just set this to 20. And then next we're going to declare another public float. And this is going to be our wall jump time. So unlike our normal jump where we set the velocity and then immediately transition to our in-air state, we're going to stay in the wall jump state for a certain amount of time. This is going to stop us from wall jumping and then immediately being able to move back to the wall. A similar system to this can be seen in games like Celeste. So by default, let's just set this equal to 0.4. And then finally, we need to have our wall jump angle. So public vector2, call it wall jump angle. And let's just set it equal to a new vector2. And we'll give it the default values of 1 for the x and 2 for the y. Okay, now we're ready to set our velocity in our player wall jump state. So in the enter function, let's go ahead and say player.setVelocity, and we're going to pass in player data dot wall jump velocity, and then our angle is again going to be player data dot wall jump angle, and finally our direction is just wall jump direction. Now after we set the velocity, if we want our player to be facing the direction we're jumping, we can just say player dot check if should flip, and to this we'll just pass our wall jump direction. And then finally we just need to decrease the amount of jumps that we have left. So we'll just say player dot jump state dot decrease amount of jumps left. So that way if we wall jump and we can double jump, we can jump again. But if we only have one jump and we wall jump, we cannot jump again. And so one more thing that we need to do. So if your character has 2 jumps and you want to be able to double jump again after wall jumping, we also just need to reset the amount of jumps that we have left every time we wall jump. So at the start of the enter function, let's just say player.jumpState.reset amount of jumps left. And that's basically it for the enter function. We can now come down to our logic update function. And in here, all we need to do is pass our X and Y velocity to the animator and then see if our wall jump is done or not. So we'll just say player.anim.setFloat. And the float that we want to set is just our Y velocity. And the value we want to set it to is player.currentVelocity.y. And then next we have to set our X velocity, so player.anim.setFloat. And we want to set our X velocity. And this time we're setting it to mathf.abs player.currentVelocity.x. So that way it doesn't matter if we're moving left or right. And then next we can check if our wall jump time is over. So we'll say if time.time is greater than or equal to start time plus our player data dot wall jump time. If this is the case, we can let our superstate know that the ability is done. So is ability done equals true. Just like that. And that should basically be everything for the wall jump state so far. Let's go ahead and test it and see what happens. So as you can see, we can wall jump now. And the wall jump is quite a lot easier than it was before. Before we had to give X input and time our jump input perfectly. Now we can wall jump without giving any sort of X input. We can just keep tapping that button. But currently, as you can see, there's a problem with our wall jump or with our jump animation. So let's see what's happening there. Let's just bring up our animator to the side, click on our player, and let's see. So it seems to be stuck in our idle animation. Why is that? So it seems like in air is not getting set to true. As you can see, we have a stupid little spelling mistake, so it's in air. So with that fixed, this should work now. Boom. And as you can see, so if we jump on this wall, we really can't jump up just one wall. We do need 2 walls to be able to jump up all the way. Perfect, so this is working quite well, and as you can see, that was so easy to add with this state system. The next thing we need to do is, let's add a transition from our is touching wall state to our wall jump state, so that way if we're, say, holding onto the wall and we give a jump input, that will go into the wall jump, or if we're wall sliding, or whatever. So let's go ahead and open up our is touching wall super state, or player touching wall super state. So the first thing we need to do is read in our jump input. So let's create another protected bool, and we'll just call it jump input. Then let's go down to our logic update function and add that in there. So jump input equals player dot input handler dot jump input, like that. And so now before this first if, let's just turn this into an else if, and then let's add an if, and this time our condition is just jump input. Because in the case of these states, we already know we're touching a wall, so there's no need to add it to the if statement. And then we just need to say player dot wall jump state dot determine wall jump direction, and we pass it our is touching wall, and then we just need to transition to the wall jump. So state machine dot change state to player dot wall jump state. And now I just realized I forgot something else. We also have to use our jump input. So player dot input handler dot use jump input. And let's just go ahead and copy that, because we also have to do this in our player in air state. So here. Honestly, I'm going to keep forgetting to do this. So maybe instead of putting it here, let's just go ahead and go to our player jump state and add that to our enter function. And let's also add that to our player wall jump state enter function, like that. Then that'll mean we no longer have to remember to call this function. So in our player in air state, we can remove that, and also over here. Then in our player touching wall state, let's remove it from here. And then we also have to remove it from our player grounded state. So let's go ahead and open that up. So jump input, use jump input. Get rid of that. Perfect. Okay, so now we no longer need to remember to do that. So let's go ahead and see if we can wall jump from our wall slide. So say we're jumping up the wall and we start wall sliding. Okay, so not quite what we want. But let's try some other ones. So if we're wall climbing and we wall jump, it's also not working. So let's go ahead and take a look at those states again. So what's happening now is in our logic update for our wall slide state, we're again first calling the logic update for our player touching wall state, which triggers our wall jump transition. But then again, we come back here and here we set the velocity again. So it looks like we're going to want to encapsulate everything in our not is exiting state Boolean. So let's just create another if statement and just say not is exiting state. And let's just move this all in there, and then we can get rid of this condition over here. Okay, so now this velocity will only get set if we're not busy exiting the state. So let's take a look at our player wall grab state as well. This is also not going to work because we're calling hold position over here, but in this case we can just move it in here as we already have this big if statement. And then in our player wall climb state, the same thing is happening. So if not is exiting state, then do all of this. And again, we can remove this second condition from the if statement. Okay, so now our transition to our wall jump state should be working. So normal wall jump works. If we hold control, we can wall jump. If we're climbing, we can wall jump. And if we're sliding, we can also wall jump. Everything works perfectly. But now say somebody's getting a little bit excited, and as they're wall jumping, they're giving X input. You'll see that sometimes if you give X directional input right before attempting to wall jump, the wall jump won't work as intended. Instead, it'll just jump a little bit straight up the wall, like that. So I find it quite hard to actually do that, but it's still something that we don't want. So let's really think about why that is happening. Let's take a look at our player in air state. So I think what is happening in this case, over here where we transition to our wall jump state, we pass is touching wall through to the state to determine what direction to jump in. But seeing as is touching wall is getting determined by our fixed update and not our normal update, over here in this else statement, we could be flipping a player and then getting jump input and transitioning to our wall jump state with the old is touching wall data. So really all we need to do to fix this is before we pass is touching wall to our determine wall direction function, let's just say is touching wall equals player dot check if touching wall. So that way, if we have flipped, we'll again just quickly check if we're detecting a wall in front of us, and then we'll be passing through the correct information. So let's just try that out again and see if anything happens. Okay, so as far as I can tell, it should be working correctly now, and I'm pretty sure it is. So now we just have one more thing we want to add, and that is some coyote time. So in case you are in the habit of giving X input while you wall jump, if you've moved a little bit away from the wall, you'll still be able to get your wall jump. And this is very simple to implement. So let's go back to our player in air state. And so our wall jump coyote time is going to work very similar to our normal coyote time. So let's go ahead and declare another private boolean, and we'll just call it wall jump coyote time. Then we can scroll down to the bottom and we can just create another set of functions for the coyote time. So the first one we're going to have is public void start wall jump coyote time. And this function is only going to set our wall jump coyote time equal to true. And this should be void, not void. And then next, unlike our normal coyote time, we're going to have a stop wall jump coyote time function as well. So we can just copy and paste the start one, rename this to stop. And in this case, we're going to set it to false instead. And then finally, we need our check wall jump coyote time function. So private void check wall jump coyote time. And then inside this function, we just say if wall jump coyote time is true and time.time is greater than start time plus our player data dot coyote time. Then in this case, we'll set wall jump coyote time equal to false. Okay, so I also just realized that we're using start time here, which is okay for the normal coyote time because the normal coyote time happens when we enter the function, but our wall jump coyote time could happen at any time in our player in air state. So let's go ahead and create another float specifically for our wall jump coyote time. So private float start wall jump coyote time. And then let's come down to our start wall jump coyote time function, which is over here. And so now we can no longer use this. So let's just turn it into a block body. And after we set it equal to true, we'll say start wall jump coyote time equals time dot time. And so now we just want to use this variable in here instead. So start wall jump coyote time. And now before we forget, we also just have to call this function in our logic update function. So underneath check coyote time, let's just add this in here. And that should be everything. So now how do we decide when we start this coyote time? So let's think about that for a second. We'll go back to Unity and I'll move the character around again just to help with the explanation. So say we're currently falling down the side of the wall like this. Whee! Okay, and now the player decides to give a negative X input. So our player flips and now he's facing left. And he starts moving in this direction. So what's eventually going to happen is we're no longer going to detect the wall. It's at this moment that we want to start our wall jump coyote time and give our player like 0.2 seconds to give jump input to still perform a wall jump. Of course, we don't want this coyote time to be too long where we end up wall jumping way after we don't actually want to. So what we're going to do is keep track of whether or not we're touching a wall, and then every frame we compare the status of the current wall check with the previous frame's wall check. And so if our current wall check is false, but the previous wall check was true, we know that we can start our wall jump coyote time. So let's go ahead and add that to our code. So let's come back to our player in air state. And the first thing we need to do is declare 2 more booleans. The first one is going to be old is touching wall. And the second private boolean is old is touching wall back. We can then come down to our doChecks function, and before we check to see if we're touching a wall again, we're going to save these 2 variables into these old variables. So we'll just say old is touching wall equals is touching wall, and old is touching wall back equals is touching wall back. And so now inside our doChecks function, we can also do the check to see if we should start coyote time. So we'll say if not wall jump coyote time, so the wall jump coyote time is not currently active, and not is touching wall, and not is touching wall back, and either one of our old variables is true. So we can create a bracket, and we'll just say old is touching wall, or old is touching wall back. So currently we're not touching any walls, we're not currently in coyote time, but in the previous frame we did touch a wall either in the back or the front. If this is the case, we can just go ahead and say start wall jump coyote time. And so now how do we actually use the coyote time? And that's pretty simple. We can just come down to this else if jump input and is touching wall or is touching wall back, and just add another or wall jump coyote time, just like that. Now we just need to make sure that we stop the coyote time. So if this does happen, we'll just say stop wall jump coyote time. And that should be it. So this isn't going to add a whole bunch to the game with the coyote time, but it's definitely something that you'll notice if it's not there. But the way we have it now, it really shouldn't be that noticeable. And so you just have to play around with the coyote time setting to get one that works for you. You don't want it to be too long, but you also don't want it to be too short. It's quite a balancing act. I think 0.2 works fine for me. And so yeah, there we have it. Now we have a working wall jump that works with just a single jump input. It should work with controller as well. Let's give that a try. It does quite nicely. So yeah, that's it for the wall jump. We're basically done with today's episode. And so before I go, there's just a few things I want to say. And that is that a couple of days ago, we hit 3,000 subscribers on the channel, which is absolutely insane. And I can't thank you guys enough for all the love and support that you guys give me. And so I've been thinking about ways that we can celebrate milestones like this. And I've taken some ideas from when we hit 2K, which I still haven't done anything for, but I'm finally getting there. And so the idea moving forward is every milestone that we reach, I'm going to add something to the Bardent asset pack. And what this asset pack is just a free set of assets that I've made that anybody can use in their own games. So if you want to get started with game development and you don't really feel up to the challenge of making your own art and you just want to focus on learning the programming side of things, hopefully eventually this asset pack will have everything to get you started. So the first thing that's part of this asset pack is a little character template that I've created. So these are just all the animations that this character has, except I've broken him up into all his different limbs and his head and everything. They're all on separate layers so you can see the movement of each of them clearly, and you can use this if you want to create your own character art on top of this. So I have some catching up to do for our 1K and 2K milestones, and I'll keep you guys updated on Discord when these things get released. And so the plan for that is just a simple forest tile set and a cave tile set that you guys can use. And so I've been working on those and I will release them ASAP. So yeah, I hope you guys can find some value in this asset pack. Again, thank you guys so much for all of the support. It really means a lot to me. And so before I go, I would also just like to give a huge thank you to all of my supporters and wonderful people on Patreon. And a huge special thank you to Triac, Cody Lee, Pyro Says, and Miguel Gray for your support on Patreon. You guys rock. and I hope you guys all have a wonderful day.